Hi ladies, in this video we're going to go through the application questions from 11G, so applications of trigonometry. I did notice when I was looking at the textbook online, it starts back at question 1, 2, 3, but in your physical textbook it's 16, 17, 18, so just keep that in mind. I also noticed this question here had 1, so I don't know what's going on, but you girls are pretty switched on, so I'm sure you will be fine. You'll know which question I'm doing. All right, and they're all bunched up, which is a bit annoying. So I've got the textbook open next to me, so if I sound like I'm pausing, I'm probably just looking at the book. Okay, so question 1 or 16 from your textbook. A fire spotted A fire spotter located in a tower at A saw a fire in the direction 10 degrees. Okay, so that's your bearing. And you can see here's a diagram. Might just make that a little bit bigger so we can, excuse me, just go a little bit wider? Thank you. So yeah, 10 degrees. So that's your bearing there. So C is on a bearing from A of 10 degrees. 5 kilometers to the east of A, so here at B, there's another fire spotter, and this fire spotter saw the fire in the direction 300 degrees. So that's your bearing. Okay, so you can see that diagram there. Find the distance of the fire from each tower. So here's the fire, C. Okay, I assume it hasn't actually said it on the question, but we'll assume that's your fire there. Most of the information I think is on there. So we've got 5 kilometers, got a bearing of 10. Now this is 80 degrees here. It's already put it in because we've got a right angle between north and east. And here this 30 degrees. How do they know that is 30? That is interesting. All right, so I just had to pause that. There is no way of knowing that is 30. So that's a bit of information they have just given to you. So when you're given a diagram, and you can see there's a lot of information on here, just redraw your triangle, okay? Because drawing a diagram is the difficult part. The diagram's been drawn for you. So let's just take that triangle and draw it here. Okay, so a nice green triangle. Put in the information. So we know this is 80 degrees. This is 30. And because all the angles within a triangle add up to 180, that makes this angle here, if we need it, we might not need it. What is that going to be? That's going to be 70 degrees. Okay, so you got all your angles. This is 5, so we were told that in the question, 5 kilometers. And we need to find the distance of the fire from each tower. So you can call this side X if you like, and this side Y. So we're finding X and Y. Or you could, oh, it's already been labeled A, B, C. Sorry, let's just rub that out. You could keep it as, and that, yeah, I knew you were going to come up. You could keep it as X and Y, but because the triangle's already been labeled A, B, and C, let's stick with that. So A, B, and C. And then we use lowercase a, oh gosh, that's an A, not a Q, B, C for the other sides. Now, this chapter or this section is on the sine rule, so that kind of gives us a hint on what we would use. We'd use a sine rule, but let's say we didn't know that we had to use the sine rule. You would use your flow diagram that I've given you to decide which one to use, or you could always start with using the sine rule, and if you don't have enough information, you can go on to use the cosine rule. Okay, so let's do A first. So always put your unknown first. So our unknown is A. Oh gosh, my handwriting. See, this is what 3 weeks does to you. Makes you lose your handwriting skills. Okay, and we're not going to use B because we don't know what that side is, but we know C. So I'm just going to write the formula for now. And then we substitute in what we know. So we know capital A is 80. Oh, handwriting is terrible. Little c is 5. and big C is 70. I'll just scroll down. All right, so to get rid of the sine 80, we multiply sine 80 to both sides. So we're going to be left with 5 sine 80 over sine 70. And just make sure when you put that in your calculator, you use brackets. And I'm not going to go ahead and do that because I've got a lot of videos to do tonight, and I'm sure you can put that in your calculator. Okay, let's move on to do B, so our other side. So remember, we had to work out both sides. You could use A, but you're always safer to use the information given to you, just in case we made a mistake here, then you're then using that error in another question. So I'm going to stick with C, okay, because we know what C is, and as long as we can copy it down correctly, we're all good to go. All right, so then we've got B, sine B, your angle at B is 30, lowercase c is, well, it should have been C, sorry, and then sine 70. So pretty much the same thing as what we did for A, but now we're doing it for B. So multiply both sides by sine 30. Okay, and make sure you put that in brackets. Now, on your calculator, always make sure your angles are in brackets. Probably automatically does it for you, but if you were to write sine 30 times 5, it might multiply that 30 by 5 and not the sine 30. So that's something you need to look out for. All right, I'm not going to do any more because I'm sure you can put that into your calculator. All right, question 2, a surveyor standing at point A. So this question relates to this diagram here. Oh, that's annoying, isn't it? I'm just looking at the textbook. So here's our diagram here. A surveyor standing at point A measured the angle of elevation to the top of the mountain as 30. So 30 is there, fabulous. She moved 150 meters closer, okay, to point B, and measured the angle of elevation to the top of the mountain as 45. Okay, so there is a proposal to have a strong cable from point A to the top of the mountain to carry tourists by a cable car. What is the length of the required cable? Okay, so I'll go to a new page. Always start by drawing your triangle. So you don't have to be exact, but, kind of make it look the same. That's not really the same, but it's good enough. Okay, so we've got 150. This angle here is 30. Now, I know that is 45, and because we've got a straight angle there, which adds up to 180, so this angle here must be 180 minus 45, which is 135. And then we can find this angle here, because remember, all your angles have to add up to 180. So at the moment we've got 165, so another 15 brings us up to 180. And we want to know the cable car, so this side from A to C, so we're going to label that as lowercase b. So when writing your sine rule, it's going to be b over sine b. Now, when deciding whether to use A or C, you can continue labeling your triangle. So the side opposite your angle A is lowercase a, and your side opposite angle C is lowercase c. So we actually know the C side. How fitting. We're doing a question about a cliff by the sea, and I just said seaside. Okay, so let's just fill in what we know. B over sine B is 135. Lowercase c, 150. Big case C is 15. Now, a lot of you are using solve. Please don't use solve. See how I'm writing a lot of working out? You need to really write this working out, because as I've mentioned to you before, and hopefully you've listened, that there are programs you can put on your calculator that can do this for you. So you just label your sides of your triangles or your angles, and it pops out the answer. So you need to show you're working out, otherwise you don't get any marks, because it can just be assumed that you use this program. And in Year 12, often questions are asked to show that. So you got to show you're working, not just give an answer. Okay, so you can put that into your calculator. Let's move on to question 3 or question 18 in your textbook. So question 18 and also question 19, they don't have diagrams, so that's always fun. We have to draw a diagram. Just line that over. Okay, a naval officer sighted the smoke of a volcanic island on a bearing of 44 degrees. A navigator on another ship 25 kilometers due east of the first ship saw the smoke on a bearing of 342. So when you're drawing your diagram, I always say draw it in the middle to give you enough space to figure out which direction you're going in. Or you can just read the whole question and get an idea of what it is. So I know the diagram is going to be similar to the one that we did first, question 1 or question 16 in your textbook. Okay, so let's draw a dot. Okay, so it's going to be our naval officer, and he's sighted the smoke of a volcanic island on a bearing of 44 degrees. So there's a naval officer. Oh gosh, that's supposed to be straight up for north. The volcanic island is on a bearing of 44. So if we were going east, it's 90. So we're basically halfway. Okay, so there's our lovely island with the volcano on it. This bearing here is 44 degrees. Okay, so then a navigator on another ship 25 kilometers due east. So now we're going east 25 kilometers. We don't know how far this distance is. It's only given us a bearing. So we won't, with this other bearing, it'll help you realize that this line here has to go beyond the island. Okay, 342. So here's our navigator on a ship. So if I draw north, and we want 342. So if this is west, west is at 270 degrees, north is at 360. So your bearing, if we're going from north all the way around, is going to be kind of halfway between the two. We don't have to be exact. So there's your other line. Now, that is 342. This angle here, you could work out, actually, we don't really need to work that out. We can work out this angle here, sorry. Oh, now I know where they got the 30 from. Silly me, I should have worked that out before. So 342, this angle here is going to be 342 minus 270. So if we stopped at west, it would be 270. So that's going to be 72 degrees. This angle here we also know because it's a right angle. So 90 minus 44 gives us 46. And we can also find out this angle here because they all have to add up to 180. So we've got 46 and 72 gives us 118. So I'm just pausing for a minute to make, or is it 108? No, 118. 118. Okay, so, oh no, it's not 118. What am I doing? No, that adds to 118. 62. All right, so there's our diagram, not the neatest diagram. So there's nothing wrong. No one's going to punish you for drawing another triangle actually with the information that we want. So we put in our angles, 46, this angle here, 62, and then we've got 72. Part of me feels like I should actually check whether they're right. So 100, 170, yeah, 180, good. Good to know your maths teacher can actually add up. All right, and then we've got 25 there. Now the question, what is it asking? Find the distance of each ship from the volcano. So you label your diagram A, B, and C. So there's A, B, C. Doesn't matter which one you call A, B, or C. And then A, little a is here, little b is here, and little c is here. So we have to find the distance A and B. And then question B, if the ship closest to the volcano can travel at 15 kilometers per hour, how long will it take to reach the volcano? Okay, so we'll do that in a sec. Let's just do A and B first. So we'll do A, just because, alphabetical order. And then, oops, not B, C, sorry. So A is what we want. Sine 46, 20. That's an equal sign. God, I wrote it and I'm like, what is that? 25 over sine 20. Oh, sine 62. So A is equal to 25 sine 46 over sine 62. And we're going to have to work that out in a sec. So I'm just going to write A equals for now until I get a calculator. Okay, so again, do the same thing. Use the value we had, which was C. So the angle at B, let me just scroll up. What was that? 72. And little c was 25 over sine 62. So B equals 25 sine 72 over sine 62. All right, so I'm just going to pause so I can find a calculator and actually do these calculations. So I couldn't find a calculator, but I got my phone. And the good thing about my phone is I've actually got an app that does it for me. So A is, or Y, let me just see if it's going to work now. A is 20 point, let's round it just to 2 decimal places, so 37. And B is 26.93. So the question is, we did that. And the second part of the question is, if the ship closest to the volcano, so the first ship, can travel at 15 kilometers per hour, how long will it take to reach the volcano? So we've got 20.37. Okay, so 20.37, divide that by 15. So I'm going to have to just do that on my phone. 26.37. Not 26.37, 20.7. 20.37. 1.36. We'll just round it to 2 decimal places again. And so that's 1.36 hours. Now, you're highly unlikely going to have to convert it to minutes, but if you did, that's okay. So 1 hour and then 30.36. So we take 0.36 and multiply that by 60 because there's 60 minutes. And that's going to give you 1 hour and 22 minutes. All right. Question 4. An air traffic controller, and this one doesn't have a diagram either. This is question 19 in your textbook. So, and I might just underline that. An air traffic controller at airport A receives a distress call from an aeroplane low on fuel. The bearing of the aeroplane from A was 70 degrees. From airport B, 80 kilometers north of airport A, the bearing of the aeroplane was 120 degrees. Okay, sorry, I just had an email come through, so I had to just delete what the email was and turn my notifications off. Okay, so we've got A here. sorry, just got a little bit distracted. And receives a distress call from an aeroplane low on fuel. The bearing of the aeroplane from A is 70, so always go up north, up. And because east is here at 90 degrees, 70 degrees is going to be in this, oh gosh, probably not that steep. So I might draw it again, because it shouldn't be that steep. Sometimes it doesn't matter, but it can make things difficult to understand. So let's just go yet. Oh gosh, that's a bit better. Okay, so there's your aeroplane. That angle there, because it's a bearing, is 70 degrees. Now, from airport B, 80 kilometres north of airport A, so we've got airport B directly north. So it's going to be a bit hard to draw because I've already drawn that line there. Of airport A, the plane is on a bearing of 120. So again, there's north. So we're drawing a line down like that. That bearing there is 120. And this is north. Okay, so if you wanted to draw the line going all the way up, you can. And that's 80 kilometres. What other information do we have? I think that is it. So once you've drawn your diagram, and this is your aeroplane here, which we'll label C, just draw your triangle again. Okay, it's just going to make life a lot easier. Obviously, doing it on your page, you probably draw triangles a lot better than me. Okay, so that's 70. This 120 isn't inside our triangle, but we can work that out because it's a straight angle, so it's 180, making that 60. And then here we have 30. No, we don't. Oh my gosh. 50. Here and up. Just before I said you need a maths teacher who can add up. Okay. Sorry, I'm a bit distracted from that email earlier. So just got to get things back together. Okay, so we've got A, there's B, and there's C. So which airport was closest for the aeroplane? So we label that A and this side B. So just like we did before, you need to use, and this one C, need to use side C and angle C to find A and B. I'm not going to do that because I think we've done the sine rule enough. Probably for this one, it's difficult to draw the diagram. Find the distance to which airport was closest for the aeroplane? Find the distance to the closest airport. Which airport was closest for the aeroplane? Okay. So we've done that in A, did we not? Let me just quickly check what the answer says. What question are we doing? Oh, well, which airport was closest for the aeroplane? So we would have, I mean, that would be airport A or airport B. And then you got to find the distance. Okay, so it's pretty much the same thing. Okay, so you found the answer for question B when you did question A. Question C, the co-pilot estimates fuel consumption to be 1,525 litres per 100 kilometres. The fuel gauge reads 1,400 litres. Is there enough fuel to reach the destination? So basically, we don't quite have 100 kilometres. Let me just cheat and have a look at the question. It does say yes. So basically at 1,400 litres, if you work out what proportion that is. So if I do 1,400 over 1,525, and using my trusty calculator, which is an iPhone 6S, going on 4 years nearly, which I'm very proud of. Not 4 years, 5 years. Okay, so that's 0.918. So we can do 0.918 of 100 kilometers. So just multiply that by 100. So the aeroplane can fly 91.8 kilometers. So I'm assuming A is less than that, making that we can do it. And I'm just going to cheat and have a look at the answer. So the answer for the distance for A here is 90.44. So just enough fuel to make the destination, which is good. Wouldn't want to crash an aeroplane. Okay, let's move on to question 5. And this is also question 20 in your textbook. Holly was recording the heights of tall trees in a state forest to have them registered for protection. A river prevented her from measuring the distance from the base of a particular tree. Now for this one, we've actually got a lovely diagram. Look at that, look at that river. Look how wide it is. I mean, you could probably just do a good leap over that. I mean, not really, you know, poor Holly, she could probably just leap straight over. Unless this was a huge tree. Maybe it's a huge, no, it wouldn't be a huge tree. It would be a small tree. Anyway, let's not criticize the diagrams because mine are definitely not as good as these. She recorded the angle of elevation of the top of the tree from point A as 25 degrees. Now they haven't put that in. So this angle here at A, and we'll do that in a sec, is 25 degrees. She walked 80 meters to B, and the angle of elevation is now 50. Copy the diagram and add the given information. Okay, so we don't have to draw the tree and the river. We just have to redraw the triangle. Didn't do that too well. That looks like a right angle triangle. I'm going to do that again. See, this is karma. When it's gone. The whole thing's gone. When I don't do a perfect diagram to begin with, at least it doesn't look like a right angle. It's a bit better. A, B, C. Okay, so angle of elevation is always done from the horizontal up. So when, and we haven't really done too much of angle of elevation and depression because this is actually not on the study design, but when you're doing angle of elevation, always put your arm out, and I'm actually doing it now, and I hope you're joining me. Put your arm out so it's horizontal to your body. Angle of elevation goes up, so from the horizontal up, and angle of depression goes from the horizontal down. So this is our horizontal. So angle of elevation here is 25. And this, if we kept going for our horizontal, this angle of elevation is 50. And that's not a very good diagram because that is clearly not 50 degrees. Now this is similar to question 17, or what would have it been? Question 2 from your online textbook. And she walked 80 meters. So that's 80. What other information do we know? Is there any other information? I don't think so. We can work out this angle here though, because it's a straight angle. So that's going to be 130 because your straight angle has to add up to 180. And that means we can also work out this angle here, which is going to be 155.25. So that is not very certain, 25. Okay, now we've done question A. Find the angle B, which we've done. It's 130. Find the angle C, which is 25. We've already done that. Find the length B. Okay, so when we're labeling our triangle, this is going to be A, this is going to be B, and this is going to be C. So B over sine capital B equals, now we use C, the side that we have, so C over sine C. All right, so I'm sure you can do that sine rule, and I'm going to move on to E. Use the length B as the hypotenuse in a right angle triangle ADC, and find the angle at A to find the distance DC, the height of the tree. Okay, so it took me a while to actually figure out what it was asking, but we can draw a line down here, which represents our tree. Oh, there it is, point D. And it's saying use this answer here from the previous question and find this length here, D to C. So I'm just going to draw another triangle, so a right angle triangle this time. This is D, this is C. Now, the information we have, this is still 25. And we worked out, well, we didn't, but I'm assuming that you would have worked out B. And then we have to find CD. So I'm going to call that side X. Okay, don't call it A because we've got A here. So for this one, when you get to question E, remember you have to find B. You'll just use your trig ratios because it's a right angle triangle. So we're going to use the sine ratio. If you want to label them opposite, adjacent, and hypotenuse, you can. So we're going to have sine theta equals opposite over hypotenuse. So sine 25 equals opposite is X and your hypotenuse is B. So remember we found B in the previous question. All right, girls, good stuff. I hope it made sense and I apologize, but I'm a little bit tired, so it might not make, yeah. Anyway, all good, bye.